Permutations with repetition. The number of R permutation of a set of an object with repetition allowed is n(r). So the proof here, there are n ways to select an element of the set for each of the R position in the R permutation when repetition is allowed. Hence, by the product rule, there are n(r). R permutations with repetition. For example, how many strings of length R can be formed from the uppercase letters of the English alphabet? And the solution here, the number of such strings is 26R, which is the number of R permutations of a set with 26 elements. So these are the ways to calculate. When a thing has an n different types, we have n choices each times. For example, choosing 3 of those things, the permutations are n, xn, xn, and multiplied by 3 times. More generally, choosing r of something that has n different types, the permutation are n, x, and x, then r times. So in other words, there are n possibilities for the first choice, then there are n possibilities for the second choice, and so on, multiplying each time, which is easier to write down using an exponent of r. Then the example here in the log above, there are 10 numbers to choose from 0 to 9, and we choose 3 of them. So we just simply multiply it by 3 and we will get the result. So these are the combination without repetition. So this is how lotteries work. The numbers are drawn one at a time, and if we have the lucky numbers, no matter what order, we win. So the easiest way to explain it is to assume that the order does matter. Generalized permutation and combination with repetition. This extends the basic permutation and combination concept to scenarios where object can be repeated in selections or arrangement. For example, the number of ways to arrange the letters in the word Mississippi is a generalized permutation as some letters are repeated. Similarly, the number of ways to select our object from n distinct types with repetition allowed is a generalized combination. Generalized permutations and combinations also involve counting, arrangement, and selection where order matters in permutation or does not matter in combination. In discrete mathematics, this is often used for counting problems such as determining the number of ways to arrange objects or choose a subset.